So we had talked about similar polygons. A little longer. Okay, so we talked about similar polygons, right? So we did similar polygons, which are ones that are like one's a miniature version of the other, right? All the angles are the same, but the sides, if it's like 2 to 1 or 1 to 2, right? That was your scale factor. Now we're going to specifically talk about just similar triangles. So similarity is still there, but now we're talking about just a triangle. And there's 3 ways to know that two triangles are similar. The first is angle-angle similarity. So if you have 2 angles of one triangle marked as congruent, if you have 2 triangles and, let's say these sides are not here, and you know nothing about their side lengths, then you could say that these 2 triangles are congruent if you only had 2 pairs of congruent angles. So let's say angle A was marked as congruent to angle D and angle C is marked as congruent to angle F. That right there is enough information to know that these 2 triangles are similar. So with polygons, you had to do all the angles had to match, and you had to do all the sides had to be similar, right? I mean, had to be proportional. Now, this is a shortcut, and it only works with triangles. But if I know 2 angles in one triangle are congruent to 2 angles in a second triangle, then I can state that these are similar. And this would be my similarity statement. Triangle ABC would be similar to DEF. Notice that the letters that have the single marks, which are A and D, are in the same position, and the letters that have the double marks, which are C and F, are in the same position when we name it. So the order of the letters is important again. You can, so if it asks like, why do you know that they are similar? You can either write out the words, angle, angle, similarity, or you can write this, angle, angle with that little squiggle. That little squiggle means similarity. So we're going to learn 3 of these shortcuts. They only apply to triangles. First is angle, angle. Anybody still copying that down? Okay. Second is side, angle, side, similarity. And this says that if an angle of one triangle is congruent to an angle of a second triangle, so that's the first thing you have to have, the angles, like angle A and angle D. And then the sides that include the 2 angles, meaning the ones that meet at the angle were marked, this side to this side would have to equal the ratio of this side to this side. So does 10 to 5 equal 8 to 4? What happens when you reduce both of those? They do, right? It's 2 to 1 and 2 to 1, right? This would be 2 to 1, and this would be 2 to 1. So because those are both the same and the angle is marked the same, then I can say the triangles are similar, and the reason is either write out side, angle, side similarity, or use your shortcut, SAS with that little squiggle, which means similarity. Okay, the third way is called side, side, side similarity. If the corresponding sides of 2 triangles are proportional, then the triangles are similar. So this is all 3 side lengths. So this is different than what we were doing before because, like yesterday, let's say, it was a polygon. We had to show the sides and we had to show the angles. This, there's nothing about the angles, right? But there is information on all 3 pairs of sides. So I would see, in order for them to be similar, 10 over 5 would have to equal 8 over 4 would have to equal 6 over 3. So 10 to 5 would have to equal 8 to 4 would have to equal 6 to 3. So I reduce each one of these. This is 2 to 1, 2 to 1, and 2 to 1. So these 2 triangles are similar, and your reason is side, side, side similarity. Side, side's not enough. You have to do 3. So there's 2 angles, angle, angle, side, angle, side, 2 sides and an angle, or all 3 sides. All right, so the questions are going to look something like this. It says, are the 2 triangles similar? And if so, how do you know? So remember, we have 3 options. We've got angle, angle, similarity, where two pairs of angles have to be marked as congruent. We've got side, angle, side, similarity, where you've got to have one pair of congruent sides, and one pair of congruent angles, and then the sides of two sides have to be proportional. Or we've got side, 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 similarity, which is all three sides in one are proportion to all three sides in the other. Angle, angle, so two pairs of angles. So if you look at A, what kinds of information do you know about those two triangles? There's two pairs of angles marked as congruent, right? This one is congruent to this one. And the other one's 90 degrees, but 90 degrees is going to equal 90 degrees. So this is yes. And the reason is angle, angle, similarity. Yeah, because it's not saying they're congruent. So if you remember, you had also ones that made them congruent. This is different. It's similar. So you can either write out the word similarity or you can put the squiggle. All right, now look at B. Okay, what do you have there that you can notice right off the bat? You've got 40 and 40, right? So I've got one pair of congruent angles, right? But then the other ones are not matching, but there's still an unknown angle there. So if I wanted to figure out what measure this is, how would I do that? Good. So 40 plus 80 is 120. Subtract it from 180, and I get 60 degrees. So either this one or this one would have to equal 60 degrees, and the other one would have to equal 40. It's not going to happen, right? If you want to double check, you can find this angle, 45 plus 40. I'm sorry, not 45. It would have to equal 80 or 40. Add these two together, I get 85. Subtract that from 180, and I get 95. So I only have one pair of angles that are congruent. I need two. These are not similar. So if you're basing it solely on angles, you need two pairs of angles that are similar. Okay, now it says, are the two triangles similar? So it's still a yes, no in the beginning. But if it's a yes, write a similarity statement, which is which triangle is congruent to which triangle. So let's look at A first. A gives you these two triangles. What can you do? So I can match up my sides. I have lengths on all three sides, right? So I can match up all three sides. Smallest in the top is 5. It's going to go over smallest in the bottom, which is 10. Middle length in the top is what? 12. Going to go over middle length in the bottom, which is 24. Largest in the top, 13, is going to go largest in the bottom, which is 26. Now I want to see if these will reduce to the same fraction. They're all what? They're all 1/2. This would be 1 to 2, 1 to 2, and 1 to 2. So if they are all three the same simplified ratio, then it's a yes. The reason is side, side, side similarity. And my similarity statement is that triangle, and it doesn't matter which one I pick first, but if I pick, let's say I say DPL is similar to, now the orders of what follows matters. So DP is the middle length side, and then I went D to P, and then P to L, that's the smallest side. I have to follow that same pattern in the second one. So what's the middle length side in that second one? SK. What's the smallest side? KR, right? So I have to go SKR. So the order of the letters is important once you state the first one. So however you pick the first one to be, you pick the first one to be. But once you pick that, you have to go in that order. Alyssa. So good question, because you can also use side, angle, side, because of that right angle. So this right angle is congruent to this right angle. If I use side, angle, side, then I have to have one pair of angles, which I have. And then I would only need 12 to 24 and 5 to 10. You only need 2 side lengths. So you could actually do side, 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 or side, angle, side. If you didn't have the angle, you had to use side, side, side. If you only had two pairs of sides, you had to use side, angle, side.
So how many answers do you have for this?
It depends, like how many parts of your answer or how many possibilities.
Like over solving this, how many answers?
There could be more than one, but usually there's one.
Solve that, answer just side, 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 side.
Right. So you don't have to list all the ways. You could just give me one way. But not all the time will there be two options. Like if you look back on the last one, it was only angle, angle. All right, now look at B. Do I have all three side lengths for both triangles? No. So I can rule out side, side, side. So think about all the ways you could do it. Side, 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 angle, side, or angle, angle. Okay? I don't have all three side lengths, so I can rule that one out right away. Do I have two sides and an included angle? What's true about angle T? If this is one triangle and this is the other, is T part of both of them?
Yes.
Yeah, that's called the reflexive angle, right? So it's part of both, which means you do have the angle. Now you've got to figure out if this side to this whole side is equal to this side to this whole side. So is 10 to 14 equal to 12 to this would be 16.5. I have to get the whole side. So the side for the small triangle is 10, right? But the side for the big triangle is 10 plus 4. And then on the bottom, the side for the small triangle is 12. The side for the big side is 16.5. How do I reduce 10 over 14? It becomes, divide by 2, right? So it becomes 5 over 7. How do I get rid of a decimal in a fraction? You can move it over 1. What you do to the bottom, you have to do to the top. So that would be 120 over 16.5, or 165. Or you could do what? You actually have a choice this time. How do I get rid of a 0.5? Multiply, right? Just double it. So you could do that too, okay? So you can move the decimal one place, and then I'd have to reduce this. So what's an easy thing to go into both 120 and 165? What happens if they end in 0 and 5? They're both 5, right? So I could do 120 divided by 5. It's 2, 4. So that's 24 over, and then do 165 divided by 5. That's 3. 3. Is there a number that goes into both 24 and 33? 3. How many times does it go into 24?
8.
And 33? 11. Is that as reduced as it gets? Yeah, so is this the same as that? No, these are not similar. So again, 3 ways to prove they're similar. Angle, angle, similarity, and for those you have to have 2 pairs of congruent angles. Side, angle, side, similarity, and you'd have to have 2 sides, so like A, let's say 10 to 5 and 8 to 4, and the included angle, so where those 2 angles meet. And then the last one is side, side, side. And that's where you'd have to have all 3 sides that are proportional. Questions on anything we talked about today? Okay, so I'm going to open your assignment, and then while you're working, I'm going to call you up to show you your quiz from yesterday if you were here.